Okay. Let's begin today's stream and continue the struggles of implementing water, but it's fun struggles. And good morning once again, Fabic. Hope you had a wonderful weekend. So, as I mentioned in my Discord channel, summer is here, and my streaming schedule will be a little bit more sporadic going forward. So for instance, this week I will only be able to stream 3 days, and it's going to be pretty short streams. Next week I will stream 5 days, but also shorter streams. And then, hopefully, I can do some longer streams the week after that one. But yeah, I know. Unfortunately, I got some other commitments in the coming months. But yeah, that's how it is sometimes. Hopefully, hopefully, we'll still manage to get some progress going. I hear you, Fabic. Hopefully we can make it up with longer streams some of these summer weeks. We'll see. But okay, the idea is to implement water terraforming now. And I think today we're going to, first of all, we're going to define it a little bit better, what kind of data we have to work with, and then we're gonna take a detailed look into flood fill algorithm, because I think we can use that one. Unfortunately, I didn't get as much reading time as I would like this weekend, so yeah, my knowledge is pretty much where it was last Friday. What's up, Derek? Hope you had a wonderful weekend as well. Time to start night streaming. Maybe. We'll see. I have a lot of life puzzle, you know. There's a lot of things that need to line up. But okay, so this is probably what we will be working with this summer, I would say. In some capacity. Both how it works and how it looks. Yes. General information, maybe. The water system will have to work with position. We'll have to work with 2 data types, data structures. So we'll mainly depend on 2 variables. One 2D variable position. Let's do it like this. Position. A world space position in the X and Z direction, and water amount. A float representing 0 to 1, representing the water amount at a given let's do it like this. Like, these are the 2 variables I would like the water system to depend on the most. And actually, mainly depend, I say mainly depend, we're probably gonna have to introduce... we're gonna introduce one more thing actually. So it's going to be 3. A float representing the height y direction at a given position. And I think these 3 will be enough. So given this one and this one together, we actually have position in world space in all 3 dimensions. It's just that we're gonna have to do some conversion ourselves. Like, oops, I've been thinking about this a little bit. So it's pretty much like we're gonna work with a 3-dimensional voxel-based texture. But when it comes to the voxels in the y direction, we're gonna have to calculate them ourselves. So we know how big a voxel is in the x and z direction. And given the height and water amount, we're gonna have to calculate how many voxels we move in the y direction. It's gonna be a little bit more mess. Yes, and before we continue, I also want to... I think we're gonna make this material we have here, we're gonna make it a little bit more debug friendly. So we're gonna be able to... we're gonna make it so that we're able to change the visuals of it. So instead of having this grid shown, we're gonna be able to press a button and we can show the different textures. So we can show height texture, water texture, grass texture, and so on. For easy debugging. I think that's gonna be very helpful when we implement the water shader later on. I wonder though if I want to pack that into this one, or if I want to create a new one. I think we're just gonna pack it in here, honestly. Or. Nah, let's create a new one. Terrain debug shader. Will the water remove the grass? Ooh, that's a very good question. Damn, that's a good question. I haven't really thought about it from a game perspective, like how I want it to work in game. Ooh. I wonder. Wow, that's like I could go either way there, I think. And you could also make it so that I think we can make it pretty easy so that water or grass that is underneath water has a different look, so it looks more like seaweed-ish than actual grass. So then we could just do, like, if you add water to a grass area, the grass underneath the water will change a tiny bit, the visuals of it. And yes, grass wind direction gets overwritten by water flow direction if underwater. Damn. Yeah, good question, and that would be very cool. But when you remove water, it will revert to normal grass. Yeah, like, it's a very cool. I think we're gonna keep the grass. And one could think that, so in the grass shader, we read, let's see, we read. Why do I always have here? We read the terrain data here. So at this point, we actually have the terrain data, and the water will be in the blue channel, probably. So we can just change, like, based on what we have in the blue channel, we multiply these variables with it. We maybe multiply, when we calculate the color here, we multiply by the water amount. So it wouldn't be that costly to change the visuals of the grass based on the water amount. And then, if we want to do what Derek says, which I probably want to do because that sounds amazing, instead of creating wind properties here and instantiating wind properties, so instead of reading a wind texture, we read the flow texture, which will probably be in terrain data alpha channel. So it's just about multiplying these with some terrain data values or some additional values, and then instead of creating wind properties from wind texture, weather texture, we do it from the flow texture or the gradient texture. That would be very cool. That would actually be amazing. Wow. Let's see here. What do we have? Appendix, references. Let's see here. Ideas. Will water. Decide if the addition of water will remove grass, or if grass will be able to be located underwater. If allowing for grass underwater, make the grass visuals change. Dynamic. Fuck, that would be amazing, I think. And if allowing for grass underwater, base bending on gradient, or let's see here. Instead of weather texture. I think it's too cool to not let... It's too cool to not allow for water underneath. Like if we... If we just do... let's see here. Terraform. I don't know. Like I wonder... Now we just have a transparent plane here. Probably gonna look a little bit better, but like if you do add some blurring to it as well, might actually get away with just not changing the visuals of it too much. Of the grass, I mean. Yeah, let's go. Like, yeah, I don't know if we need to change it too much actually when it's underwater. Maybe make it a bit more sparse. We can reduce the sparseness of it. I don't know how it would look. Yeah. Yeah, it looks pretty good, and now we only have a semi-badly implemented transparency material with some blurring underneath. We still have some things to do there. We can see the outlines becoming a little bit not as wide when we're in front of the water, but yeah, that's okay. Yeah, love the input. Like, great question. I haven't really thought about it, but yeah, we're definitely going to support water underwater. Grass underwater, I mean. And definitely gonna make it depend on water flow more than wind. Good morning, Harukanen. Hope you had a wonderful weekend. Yeah, so great input. But we're gonna leave it down here for now. The first issue we must solve is, yeah, fixing this. Yeah, water underwater. But okay. Let's move on real quick to... I want to do terrain debug shader. A nice thing to have. I've had a very simple one previously, but let's make a bit more complicated one. Render type opaque. Yeah, we can go with that. And we're gonna do these instead, and we're gonna go with HLSL program and HLSL. Vertex fragment. And I'm going to do vertex shader input, I think it is, and vertex shader output. And we don't want these here. Good morning, Geralt. Hope you had a wonderful weekend. And then what do we have? Position, object space, UV, yeah. Position, clip space. Maybe I should look into, I haven't worked that much with it, but like initial templates. Like I would love to be able to create, like I want to add my own rules. So when I create a new HLSL shader, I want it to start with some, I want it to look like this basically when we start it, or something like this. Let's go input. What's up, Meister K? Thank you so much for the Prime, appreciate it. Hope you had a wonderful weekend as well. Vertex shader output, input. Add a bool if the water is underwater, yeah, we will do that. Okay, basically this one is going to be very simple. We're going to do this. vertex shader output, vertex input, and then we do output dot position cs is equal to position cs, and output uv is equal to uv. I don't think the vertex shader will be more complicated than this. We will do most of the logic here in fragment shader. What's up, Skittles? What kind of game? Honestly, I get that question a lot. So recently I've just begun referring to 3 other games which are highly like inspiration. Not like Pokemon, but if you have played Viva Pinata or Chao Garden in Sonic, or just plain old Tamagotchi, more like that type of creature collecting game. I hope one of those at least rings a bell. Love them all. So what we're gonna do also in this shader, we're gonna support the same grid we have in the procedural grass terrain. So we're just gonna take all of these, put them in here, and we're also gonna have our terrain data texture. So very retro. Like those 3 games are very inspirational. We're gonna go off in a tiny bit of a different direction. I can show you what we have so far and explain a little bit more in depth soon. I think we're gonna have these here as well. So basically the player will control a character. Currently he looks like this, but that's up for change. The player will be given a plot of land, in this case roughly the size of this one, initially a little bit smaller, and the player will have to purchase more land. So the player will be given a plot of land, and then he or she are going to be able to terraform it, adding heights or pools of water or whatever, and grass, let's see, and plant flowers and trees and whatnot. So he or she will take care of this plot of land, and depending on how he or she creates it, creatures want to move into this garden, and then you take care of the creatures. Something like that. Make a giant hill and be king of the hill. That will be an option. Definitely. Good morning, Defesmo. At this point you should record a message that explains your game after you push a shortcut. Yeah, maybe. Like doing a new YouTube video explaining the game at its current state and such. That wouldn't be too bad of an idea. But or like the most simple way is just have a chat command, exclamation point, game or something like that. Seeing the graphics explains a lot. Yeah, indeed it does. Okay, so let's move on to this shader now. So we're currently in the process of adding water to this garden, water terraforming, and I think we have pretty much converged to how we want the water to work. The player will be able to create rivers and lakes, and we're gonna have an underlying simple fluid system for it that breaks real world physics a bit. So we're just in the beginning of creating the underlying system for the water, and something I should have done before is creating a terrain debug shader, or a advanced terrain debug shader, and we're in the process of doing that right now. So this terrain debug shader will basically just be a grid shader, much like the one we have already, this one, but we will be able to change what it shows. So if we press 1, it will render the height map. If we press 2, it will render the grass map. If we press 3, it will render the water map. And then we can do some testing, try the physics and whatnot. Good morning, by the way, Namida. Hope you had a wonderful weekend. Yeah, the player will be able to create a tall hill, and on top of that hill he or she can create a small pond, and then he or she can create like a river going down from that hill down to a big pond way lower down. And then our fluid system will try to calculate a stable state based on those parameters, and then we will spawn the water as a lake, a river flowing down from it down to another lake. And that's where we break real-time physics, because in a real world the river should drain the lake that is higher up and add all the water to the lake down below. But we will simulate it like if the lake up on top always has an influx of water and the lake at the bottom always has an outflux of water. But we want to do it in such a way that we don't need to add actual influxes and outfluxes. Yeah, it's gonna be complicated, but I think it will be a fun adventure. Exactly. So, like after the creation of a lake, or after the creation of ponds of water and rivers, the height, like the water level in those ponds, will stay the same. And then when the player adds more water or removes water, that's when we recalculate the new heights, and then they will stay the same. Okay, do we already have an error with this shader? We do. Position CS. Yeah. Yeah, fixed 4. We're gonna go with float 4 here. Float 4 here. And actually we can skip all of this. We're gonna do... I wonder if in this terrain here we have a function called... where do we have it? Calculate grid values here. I think we're gonna move this one into one of our utility files, or possibly create a new one. Calculate grid value, position world space, grid delta, grid line width. I think. Yeah, we are. If it spills over, does it stay or dissipate? Depends on what you mean by spill over. Yeah, okay, so if the player fills up a hole in the ground with water, yeah, that is going to be the hard part. Like, we want to calculate... I had a nice drawing last Friday. I'm gonna add the exact same drawing again real quick in GIMP. Maybe I should even save it, which will explain it a little bit more. 256. Yeah, how... $48, $20, what do we have? 16, 32, 64. So for instance, I don't remember, I think I remember how it looked. Did it look something like this? Yeah, so for instance, if we have terrain like this, and the player adds water to this point, depending on how much water, it will appear different, right? So if you just add this amount of water, we get a little bit of a pond. If he or she adds this much, we get a little bit of a pond. The interesting parts start if we add even more. So let's say that we add an amount here, then it will start spilling over. So we will get here, then we will get a little bit of a river, and then we will get a new pond here. And this is our new stable state. So pond, pond, river. If he or she adds even more, we could maybe get to a state like this. Pond, pond, tiny little bit of a river. And then if he or she adds a lot of water, we will get a state of like this. So one big pond. Yeah, how am I going to handle this? This is going to be the the problem to solve, basically. But I think we can do it. So it's like to the fluid, quote unquote fluid simulation, we add water, we add X amount of water at a point, and then the fluid simulation calculates the next stable state, and when that is done, that's when we spawn water based on the result of that one. And then, like, as long as the player doesn't add water or remove water, this will be the stable state. So it will just look like this. No matter if we jump into the water and, I don't know, water splashes out, it will still be this stable. So yeah, the fluid solver is going to carry the heavy load of this. Let's see here, where do we have it? Shader utils, util, lighting, math, and random. Yeah, we want to add some new one here. And it's going to be, we're going to name it to something unoriginal. It's going to be util helper functions. Util helper functions. Fabric, how far can it travel? So we're talking about the water. How far it can travel will depend on the amount of water that the player adds here. Like, we're gonna take a look at flood fill algorithm and see if we can implement it using that one, because the idea is basically like we had last Friday. We add some amount of water here, and then when we flood fill in all directions, we reduce that amount the further away we go. So it will depend on that one. So we could have a case where we add water here, we get enough water to start going out here, but then the further we travel, the less water we have. So we could get a stable state like this as well. A pond of water and a river, but the river dries out. So we didn't add enough water here to make the river all the way to create a new pond. So yeah, you have something like if we would have a case of this, you mean? That is true. Like, depending on the logic we implement, it's going to look something like I wonder if we're gonna get something like this. And when it comes to this one, like if we just have a water mesh that looks like this, it's going to look a little bit ugly. But depending on so this voxel, for instance, will have a water value of 0.1 or something like that. If we have a water value of 0.1, we might add patches to it. So from above it would look like a pond here that goes out a tiny bit here, but with missing parts like this. So here we have a lot of water, here we have very little water that disperses. That's what I think. Does that make any sense? Skittles, so there's no chance that if I make some extra small diverts around the place unintentionally, I won't have random blobs of water everywhere. That is true. If we, for instance, add if we have a state like this and the player digs a new hole here, then we're also going to have to recalculate the water. So like we dig a new hole here, we don't want to get a state where we have a wall of water here. So then we're gonna have to check, like we're gonna take the values we have here and disperse them here, and we might get a new result like this. So that is true. So I wonder if, let's see here, general information. Water, let's see here, or actually fluid solver. The only times the fluid solver when the fluid solver will be activated to calculate a new stable state are the following. The player adds water, the player removes water, I'm a little bit uncertain. I haven't really decided exactly when this will be the case. If the player removes the water by adding dirt to it, or if the player removes the water by draining, by drainage, we'll see. But then we'll see. The player changes the terrain height at an area overlapping water. So the question is if we will have this one, or if this one will be included in this case. You can easily check if terrain has water when you are terraforming it. Just mark water as unstable and recalculate it until stable. Yes, that's something like that is probably what we're gonna do. That sounds like a good idea. I wonder how. We'll see how we'll actually implement it. So slowly but surely we're going to converge onto a solution we're happy with. Then it's just a question of exactly how we implement it with the data structures we have at our disposal. I never thought this would be easy, but I think this will be, it will be very fun. Okay, so where do we have util helper functions? Let's move this one in here. So calculate grid value delta. We're going to rename this one to grid delta. Makes sense. And then we're going to rename this one to grid line width. So just a function for calculating a grid value. Given a position world space, a grid delta in world space. So given 3 arguments in world space, we return a value that is either 0 or 1. 1 if it's in a grid, 0 if it's not. And then we use this one, terrain procedural grass, calculate grid value. Let's do calculate grid value. We didn't change the name of this one, so we should be able to just remove it from here, and this one will call the included one instead. Beautiful. Ooh, do we want this one? Let's do it without it for now. Very simple shader. Let's see if it works. Although terrain base, oh yeah, we need to add like this. $76. Okay, we still want position world space here. Yes. And then we need to send it onward. Undeclared identifier, yes, because we need to include this one as well. Yeah. Yeah, in this case I think we're gonna replace this one with return ground color. Okay, there we go. Let's see if we can make a new material. Terrain debug material. Oh, that's not the correct one. Yeah, okay, I think we have the grid values here. So let's do we're gonna do, let's try and replace. So in the setup of our environment, right now we send in procedural grass terrain material. Let's send in terrain debug material instead. Although I would like to be able to flip between those two as well, I think. Yeah, there we go. A lot of aliasing, a lot of wrong widths, but okay, I think this is a good start. So actually, let's do this. Terrain base. And we have material here. Terrain visuals, test flags. Let's see here. Debug material. So the idea is that we can prompt our, so in game during runtime we can prompt our terrain to switch between debug material and terrain, or this plain material. Yes, we're gonna have to add, if we go to terrain patch, we already have a set material here, and then we set, we actually set all of these. This is wonderful. I think this is all the properties we need to set. So I would like to add a generate, and then we add a public void change terrain. Or let's do toggle debug visuals. And I wonder if we just want to do toggle, though. We're gonna do set debug visuals, and then I wonder what I want to send in here. Ooh, how cleanly am I going to implement this? I wonder if we want to introduce an additional enum, environment, terraform terrain. And how spread out I want it to be. Let's do it pretty straightforward but ugly this time around, and then I will just have to change things around the more complicated it gets. But terrain here, so we're gonna do terrain debug, terrain debug mode. Yeah. I want to name it gradient for now, so yeah, we can do it like that. Debug environment using yeah. And now let's just do it like terrain debug mode, and then we do fuck, did I just name it material up here? Yeah, we did. Material is equal to debug material, and I'm gonna add some additional properties setups, but for now, and then we do for each terrain patch in terrain patches, set material. And let's just do this for now. Clear generate. After we have generated this, let's do if test flag 1. Grid. Okay. Oh, whoa, 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 whoop, whoop, whoop. Yeah, let's make it a bit more specified. Because we have namespace game. Okay, so environment, no test flags, so we should just spawn it with terrain material. We have changed that one. Terrain, procedural grass terrain material. And we have terrain test data. Terrain debug material. Okay, let's see. So now we should just spawn the terrain as it previously looked. Good. And we can add grass. Okay, so nothing has changed. But if we do environment and we change test flag 1 to be true, we get this instead. And it seems to be true. Good. Let's just fix this debug material. It's going to look exactly like procedural grass terrain material, except our terrain base color is going to be, and grid mesh is going to be a little bit different. But what values do we have? 0.0211. Can we do, no. 0.0211, 0.2, 0.04, 1. And then we do super 5. Yeah, something like that. Right. Okay, so I can imagine us having to flip between these different debug modes quite frequently. So we're gonna add some input to the default input actions. Although I wonder, we might want to add an additional action map here, that is debug input. And how will that exactly work with input handler? I think we're going to introduce a debug input handler as well. Would that be weird? Or would it be enough with... Nah, I think we want to add one, but it's gonna be way simpler than this one. I'm pretty sure. But in that case, I'm wondering... Yeah, I probably want to do it like this. Game. Scripts. Yeah, let's do it like this for now. Debug terrain mode. Debug, I don't know. Probably gonna rename it later on as well. Okay, and then we're gonna introduce debug input, I think. I think we're gonna skip that one. No, we're gonna do it, but we're not gonna destroy game object, we're gonna destroy this. something like that. And then we want is it input action? Yes. And let's see. Let's see what we get with something like this. And I'm just gonna stack this one here. Input action. Is it with one modifier? Yes, it is. W for tear. Thank you for the follow, appreciate it. Modifier, listen, control. Or actually, do we have one more specific? Left control. Yeah. And binding, listen, 1. So control 1 gives us debug mode 1 action. I want to rename it. Let's keep it like that. But I would like to add processors. So I want to double check what we have here. How do we want to write this? It's like this, and then yeah, I think so. Enable actions, instantiate events, and then we're gonna do like I think I would eventually, I think I want to have one additional layer between this method. So one, yeah, I think. Not entirely sure, but we should be able to do clear, regenerate, private void, start. If let's keep it simple. Debug input handler debug mode of one event plus equals 2 we're gonna do I wonder if we're gonna do it like this. Nah, let's keep it like this. And then we do debug one mode event plus equals 2, or actually add listener set debug mode grid. Is that how we want to do it? Oh yeah, of course. We're actually gonna have to do I wonder if we might as well keep it even simpler. I wonder if we're gonna do this. We're gonna remove this abstraction and just do private input action debug one mode. Let's try and do serialize field, get private set public, and we just do debug mode one action dot performed plus equals 2 set debug mode like this. Don't we have the .log? Okay, and then we can do let's just see if this works. So if we press Control 1, Okay, that one is Unity engine actually uses that one. But did we get the bug? Oh fuck. Let's see. Set debug mode. Set debug. No, we did not. So Control 1 is already bound to, okay, so Unity Editor uses that one to flip between main tabs here, so we might want to change that one, that's for sure. 2, yeah, we don't get any change here. That's weird. We have input handler. Oh, did I? Yeah, of course. Okay. That explains it. So when we changed the visibility of this one, it also got reset. Let's remove events. We're not going to use events this time around. So we just do like this. Good morning, Wesley. Hope you had a wonderful weekend. So we just keep it like this. And we want to recreate this action. But okay, so we don't want to use Control 1, because if we check Control 1 here, Control 1, yeah, we definitely we don't want to use those. I got the whole week off. Oh, nice. Enjoy. Input action with one modifier. Debug action 1. Okay, so I don't want to use shift. Let's take a look. Okay. Let's try shift. Well, I don't want to use control, but if we do shift 1, nothing happens. Okay, so let's use shift instead. Input handler, debug action 1, modifier, left shift, binding 1. Let's try this one now. So shift 1 should prompt the debug mode to change, although I wonder if shift 1, yeah, it does. Beautiful. But I think we're going to keep it like this. So shift 1 should be equal to debug mode none. Debug action 1. So let's add debug action 2. This. Oh, one sec. Of course, that's not how we want to do it. I guess we could do it with stacking multiple ones and add processors to them. But let's just do it like this for now. Debug mode 2 action. debug action 2, and then we do terrain base none and to grid. Yeah, right now we're just prepping the terrain to be able to switch between modes before we start implementing the water system. So like, I want to be able to run around in the world and press Shift 4 for instance, and that will make the full terrain be just a plain, but we visualize the water data. So that's basically what we want to do. So yeah, so I want to be able to show like the underlying data in the in-game world. That's what we're trying to do right now. Yeah, so now we should be able to switch between the terrain, how it should look, and the debug grid. So if we add some grass here, and then we can do, or we should be able to do Shift 2, and then we just get the grid without the grass, and then we can do Shift 1 and we get back how it should be. Shift 2, Shift 1. Okay, that's pretty nice. And then I want to do yeah, now we're gonna do a bit more. Let's see here. Terrain debug shader. I want to introduce a mode here. And I'm not entirely, I still don't know entirely how to do this right from my head. So we're gonna take a look at terrain procedural grass. More specifically, this one, keyword enum. Oh, we don't even use this one anymore. Should remove this one. But we can do keyword enum. I think so. This 0, 1, 2. And here we want to do. We want to copy this one and we want to add it here. I think we actually, let's leave this one visible for now, and we're going to rename it terrain data debug mode. Good morning, Desai. Hope you had a wonderful weekend. Terrain data debug mode. And then we do none grid. I want to see here, I want to compare with none grid height grass water gradient. And then we have defined this one here. Then we want to do shader features, and then we can do fdiff and elif and whatever. So I wonder if we can do it like shader feature terrain data debug mode none. I wonder if we can define them each on a new line like this. Not too sure. What do we have? We have 6 of them. none grid height grass water gradient, and then we do none. Actually doesn't really exist here, but yeah, let's just try and do if def debug mode none elif grid and if. I think we're gonna do it like this. If def else return 0. If grid, then we do all of this. Yeah, let's try it. Unrecognized identifier. Oh, isn't it like... Can't you do something like... Is it this one? Can we do... Yeah, let's just see if this works first, and then we can see how we can introduce a new line with the compiler. Okay, beautiful. Let's try this one first of all. And then we do debug mode shift 1, 2. Yeah, then we have full black. And if we take this one and we change this one to terrain debug mode grid. Ah, beautiful. Nice. So then I wonder if we can do... let's see here. HLSL new line shader feature. I actually think that might work. Beautiful. Okay, something like that, but then we need to set these from the script as well. And I would love to be able to set them like, so we do terrain base, material debug material. Here we do have debug terrain mode. So I wonder if we can do material dot set int. Terrain data debug mode. because I want to be able to set it like this, and then we do debug we want some fall through here. I guess we could do case none, do this, and then depending on how we implement this, we can do debug material set int debug terrain mode dot. Oh yeah, we want to do this as well. This mode, but we don't care about this one here. Like this, and then when we set we do int debug terrain mode. So if we don't have debug terrain mode none, we do material debug material, and we do set int shader property name, and then we convert this enum to an integer, debug terrain mode. So that would give us 0 for none, 1 for grid, height, grass, and these do match this one. 0, 1, 2, I think. Let's try this. Yeah, so now when we switch to debug mode, we should be seeing the grid, I think. I hope. Yeah, beautiful. Oh, we don't have any. Okay, that's interesting. Yeah, we just set that one once. Okay, we need to fix that as well. So right now the grass doesn't have, we don't have a wind texture in it, because when we switch and then switch back, we don't set the wind texture. That is true. But let's wait with that one. So what I want to do next is I think we're going to do it like this. elif returns elif none else, and here we're going to do some additional things. We're going to do terrain procedural grass. We want to read this one basically. So we want to read this one. Terrain data UV, input UV, terrain data texture UV scale, terrain data texture UV offset, and then we sample texture. And depending on the result here, we're going to do if def terrain height grass water And then I'm actually going to do elif gradient, and then we do a else and if. So if it's height, and I think I want the color here, so we're going to do return float 4 terrain data.r 0 0 1. Return float 4 0 terrain data.g 0 1. Like, depending on what terrain data we show right now, I want it to be colored as the channel it's in. So height red, grass green, and water blue. And then for the alpha channel, we're gonna do float for terrain data.a, terrain data.a, terrain data.a 1. And finally, we should never get to this case, but here we're just gonna return terrain data as it is. Okay. Arnav, what's up? Why do you prefer Intel rather than Ryzen processor? I don't really think I have any preference there. It was just when I built this computer, Intel was pretty much the default in the computer building community, or that's how I felt it was. So yeah, if I would build a new computer today, I don't know which processor I would go with. Okay, I think this should be good enough. Let's see if we have some compiler errors. No, we don't. The boring part is going to be to add them here, but let's just add one and see if it works. And then we jump. If I've implemented everything correctly, it should be just to add one additional input action here, and then we can try it. Hopefully everything else will work. So input handler, debug, input action. This. Let's see. Shift 1 resets that one, that's okay. Shift 2, Shift 3. Okay, we actually don't have anything on Shift 3. Out of curiosity, what do you do as a full-time job? I do this part-time, and then I'm in the business of data the other time I have. Right now I don't program as the other part-time job. Yeah. I don't complain. But although, like, I have been starting to pondering the idea of picking up like freelance work, game development related freelance work, but not yet. Oh yeah, the reason we don't get any change here is of course because we haven't added nothing is listening. And this makes me think that I would probably like to clean this one up. We could make it so that the actions, the inputs, send a integer onwards. So shift 3 calls a method that takes an integer parameter, and we set that value in a post-processing way. But for now, let's just go with this. So then we set height here, and now it should work, hopefully. The wind works for the grass initially, right? Yeah, it does. But then we do shift 2, we get the grid, shift 3. Nothing happens. Did I miss something else? We should be following through to this one, set the debug terrain mode. Right? Yeah. Ooh, it actually worked. Straight out of the box, I think. I wonder though, yeah, I think it wasn't as... Let's take a look. Shift 2, shift 3. Grid, height. So we actually set the correct... We set height here. Let's do control or shift 2. Now we have them at grid, and if we do shift 3, now it should be height. But so terrain data debug mode is height, but we actually don't render the height. We don't, and we do seem to enter this one. That is weird, because we can see here, down here we have height, shift 2, grid, shift 3, okay. If we change it manually, it works. Interesting. Okay. The shader seems to do its job. Grass, height, grid, none. Very weird. But I'm afraid I'm gonna have to pick this up and figure this one out tomorrow, because as I mentioned in my Discord server, I'm unfortunately gonna have to do some shorter streams today because of other commitments, or do shorter streams this week and the next one. So I have to run now, but good progress, I think. We just need to get this in place before we can actually start experimenting with the water, the fluid solver. So yeah, during the summer here, the streams will be a little bit more sporadic, but I will try to update the times on the Discord channel. So yeah, and as always, thank you so much for watching, everybody, and have a great rest of the day. Peace.